Yeah, guys, we'll be just starting in another 2 minutes. Yep. Hello. No, I was not speaking. I was just waiting for some others to join. So now we can start. Yes. So we'll be looking at combinatorics today. So the basic concepts of permutations and combinations first. We'll have a look at that, and then we'll go on to advanced concepts. Okay. So you can hear me now, right? Yeah. Okay. So what do we mean by combinations? Okay. Combination refers to a selection. So if you have, let us say, a set of objects, say A, B, C, D, okay, and I want to select any two of them. When I say select any two, obviously the order in which you select is not important. So if you manually count, you are going to get these cases. Okay, so total 6 cases are there. How to get these 6 without actually counting? So there's a formula for this. This is what the combinations formula is, NCR, which basically is n factorial upon n minus r factorial. Okay, where n represents the number of objects, r represents the number of objects present here, okay, and number of objects you need. One thing you have to ensure is the objects must be distinct objects. You cannot have any repeated objects. Okay, identical objects are not allowed. In that case, NCR does not hold. So NCR here, in this context, n would represent 4, you need 2. So 4C2. If you calculate, 4 minus 2 is 2. So that's 24 over 4. So 6. So that's what you have got here. The 6 ways. Okay. So selection of R items from n distinct items. The order of sequence is not important. That is your NCR. Okay. Everyone okay with this? I guess this is the basic concept. Okay. I'll just quickly go through the basic concepts first, and then we'll get into questions. Next is permutation. Now, permutation refers to the ordered selection, or after you select, you arrange the items in a sequence. Okay. So, for example, if I look at this question, if I say that A, B, C, D represent the letters, and you have to make a 2-letter word, let's say simple 2-letter word with or without meaning. Okay. So, for every selection A and B, you can make two possible words, either AB or BA. They are no longer the same word because the sequence actually makes a difference. Okay. So obviously in this case, what will you get? You have already got 6 cases. In each case, you are getting 2 possibilities. So we should have 6 times 2, 12. Now, instead of doing it like this, we can simply say that, okay, you need a 2-letter word. So we'll think of 2 blank spaces that have to be filled up. We now decide in how many ways can the first blank be filled. So in this case, there are no restrictions, no conditions. So there are 4 options. So you can fill the first place in 4 ways. Okay. One of the letters is gone. Let us say A is gone. So the second blank can be filled in 3 ways. So for each of these 4 ways, this is going to be 3 ways. What I mean to say is, if I had chosen A, then here you had B or C or D, 3 ways. If I chose B, then here you will have A, C or D. That's 3 ways. C, then A, B and D. And D, then A, B and C. Right? So for this also 3 ways, for this also 3 ways, for this also 3 ways, for this also 3 ways. So it is going to be simply 4 multiplied with 3, 12 ways. Okay, in simple terms, we can say that we are basically trying to figure out the number of ways of filling the first blank and the second blank. So when you say talking of and, so you can remember a thumb rule. When you say and, you multiply. When you say or, you add. Okay, so this is basically the main idea in permutation and combination. So by looking at the question, you have to decide whether it's a question of selection or whether it's a question of an arrangement or an ordered selection. So this is the main idea. I hope this is clear. Everyone is okay with this? Anyone has any doubts? Oh yeah, I'll send you the recording. Just drop me a text message on Leland. Okay, I'll send you the recording of this. So anyone has any doubts with this? I guess this is fine. All right. So now let's look at application of this. Okay. So as I said, you can't have any repetitions here, right? What happens if there is a repetition? Say if I had the letters this, and I have to select 3, versus if I had A, B, C, D, E, F, and I have to select 3. This is straightforward. 6C3. That's done. Okay. Here we can't do that. 63, if you by the way calculate, you will get 20. I'm not doing the calculations. I mean showing the calculations. You can obviously do it at your end. But over here you can't do 63. Okay. What will you have to do is you have to make cases. Okay. So the first case is, you might say that all different letters. So as you can see that there are 3 distinct letters, A, B and C. And you are selecting all different. So it is just going to be 3C3 one way. You just select A, B and C. Second case, two same. That means two letters are same. So that could be either the A's or the B's. Okay, both have a scope of being repeated twice. So A and A. Now, when you have selected the A's, the third letter could be a B or a C. So that makes two cases here. When you have double B, again you can have A or C. So two more cases here. So that's four ways. And the third case, all three are same. That's only one possible way, B, B, and B. So that's one way. So as you can see, the total there are only six ways. The reason why I say that you cannot use the NCR formula directly in such cases. So this is the reason, because the answer will be way off. Okay. So if you have a question where you have repeated letters and yet you have to select, then the only way possible would be to make cases like this and figure it out. Now, following it up, what happens if you have identical letters or repeated letters and you have to do an arrangement? So let me remove this. So if I have, let's say, the same thing, okay, versus, so those six with these six, okay, and you have to arrange all the letters. So if you have six distinct letters, we'll think of that six slots, and then we'll proceed in the same way. First place in six ways, then 5, 4, 3, 2, and 1, right? First place in six ways, one letter gone, so you're left with 5, so 5 ways. Then one more gone, 4 letters left, 4 ways, and it goes on. They're all and, so you're basically going to just keep multiplying them. So what we get is just 6 factorial. So you can remember this: n distinct objects arranged in a line. The number of ways will be n factorial. Okay. So this is useful. Please remember this, that minded that in any question, if you are ever doing a factorial, please make sure you understand that a factorial refers to an arrangement of objects. Okay. So if there is an arrangement concept implied in the question, only then use n factorial. Otherwise, it will not be a correct thing to use. Okay. We'll come across many questions where people often think of putting a factorial, but that actually ends up being a wrong thing. So a factorial is purely for an arrangement perspective. Okay. Now coming back to this one. So how do we do it? Some of you might be knowing that it's 6 factorial. Since the two ways are same, you divide by 2 factorial. The 3 b's are same, you divide by 3 factorial. Okay. So what is the logic behind this? So why do we do it like this? So the idea is, when we are looking at all possible arrangements, think of A1 and A2. Okay. So keeping the remaining 4 unchanged, positions unchanged, if these two A's were not the same, but let's say one was A1, the other was A2, so they could have been swapped. They could have been swapped in 2 factorial ways. But since they're actually the same, the swapping does not generate in anything new. So we need to cancel that effect of the swapping, which is already implied in the 6 factorial. So to cancel the effect, we divide by the 2 factorial. And exactly the same thing we do for the 3 b's by dividing by 3 factorial. An alternative way of solving this could be that there are 6 slots. Okay. Since A's cannot be arranged, we just need to choose the slots where the A's will occur. So there are 6 places, 2 of them are A's. I'm just going to select 62. Okay. So let's say I selected this place and this place. So that's where I place the A's and I leave it there. Now there are 4 places left. I need to select 3 of the places for the B's. So I next do is 4C3 and 4C3. So let's say those 3 places are these 3. And 1 place is left for the C. So I'll just do 1C1. So nothing else to be done. If there were, let's say, some more digits. I'll show you one more time. But let's first simplify and see what this gives us. This is 6 factorial by 2 factorial 4 factorial times this, and 1c1 obviously is 1. So this cancels out. See, we have got the same answer. 6 factorial divided by 2 factorial 3 factorial. Right? So if there was one more, let us say we had A, B, B, C, D. Okay, 5 slots. Pick any two for the A's, 5, C, 2, and the remaining 3 are all distinct, right? There is no repetition or anything. So we have to arrange them. So these 3 will be arranged. We'll just multiply 3 factorial. Okay, there is no need to do a selection anymore. Whatever is left, those 3 digit letters will get arranged in those 3 positions. So it's 5C2 times, so it is as good as that 5 factorial over 2 factorial, right? So now, why is this understanding important? So let's say I give you a question where I tell you that A, E, I, P, Q, R, S. There's 7 letters. Obviously, as you can see, these 3 are vowels. Okay, the others are consonants. I am saying that you arrange them such that the vowels occur in alphabetical order, meaning they can occur anywhere in the series, 7 places. They need not be together or anything, but whenever they occur, they have to occur as A, E, I only. So we have basically constrained the arrangement of A, E, and I. So we can use a similar logic like the last one we said, that there are 7 places. Pick any 3 for the vowels. So we can pick, let's say, this, and this. So 7C3. The remaining 4 consonants can be arranged in these 4 slots in 4 factorial ways. That's your answer. Okay. And see, surprisingly, it behaves exactly as if the vowels were actually the same letter, because in effect the same thing is happening, right? The same letters could not have been arranged, so we divide by the factorial. Here the 3 vowels cannot be arranged because of the constraint given, so we divide by the factorial. So are you guys with me? So whenever there is a constraint in the arrangement that no, you are not allowed to arrange, then you essentially divide by the factorial. Okay. So can you answer one question? How many 3-digit numbers are there where the digits occur in descending order? How many 3-digit numbers are there where the digits occur in descending order? For example, 731 is where a sequence where the digits have occurred in descending order. So how many such numbers will you have of 3 digits? Anyone? I write the question. How many 3-digit numbers where the digits are in descending order? So the hundredth digit greater than the tens, greater than the units, we need the 3 digits. So what's it going to be? There are 10 options, right? 10 possible digits, 0 to 9. Just select any 3, 10C3. That's it. Okay. Why? Because as soon as you select any 3 digits, if I have to sort the number, to create the number, generate the number following that order of decreasing order, there can be only one possibility. So it's just 10C3, 120 such numbers. For example, if I select the digits 7, 3, and 1, I can only create 731. I cannot have any other number possible. So it's a simple question of just doing a selection. Okay. Let's look at another variation. This is also quite interesting and prone to mistakes. So if I, let's say, ask you that you have A, B, C, D, E, F, six people, let's say six people, and I ask you select any three. So very easy, 63, 20 ways. But if I say divide into equal groups, what do you think will be the answer now? Six. Why? Why do you think it will be six? Divide into equal groups means each group will have three people, right? Like six people, you have to split into equal groups. So each group will have three people. So what would be your answer? It's actually 63 divided by 2 factorial. I mean, 2 factorial is 2, right? So that way. Can anyone explain to me why? Why we will divide by 2? And how is this different from the previous question? So in the previous question, we just need to select any three and discard the others, right? For example, if I select ABC, so I have got ABC, I discard DEF, no problem. Okay, similarly, if I select DEF, I discard ABC, that's okay. In the second one, I need to keep both the groups, okay? So when I do 63, if I select ABC first, then the other group is DEF. But when I'm doing 63, there is a possibility that DEF gets selected, right? So the other group is ABC. So this way of splitting in two parts and this way of splitting in two parts are actually the same. But we are counting it twice. And that will happen every time. For example, you select ABD and CEF. But you could have also said CEF first and ABD. But then this way of splitting is also the same. So we should count only one of them. So every time we do a 63, I have to divide by 2 factorial because of the order that is automatically coming in. Okay. So it will be half of the number. Is it clear? 63 divided by 2 factorial. You can check it with a smaller set. Say you just have A, B, C, D. If I ask you split this in two equal parts, so your possibility would be A, B, C, D. That's one way. A, C, and B, D. That's one way. A, D, and B, C. That's one way. And you will never get any other way. All the other ways will start repeating as C, D, and AB, which is basically the same as the first one. What is this basically? So the answer is three ways. So how do you do it? 4C2 divided by 2. 4C2 is 6. Okay. Right. Let's move on to a few more different types of questions. So let us say I give you a question which is based on this condition. Okay, let's say you have got A, B, C, D as four girls, and let us say P, Q, and R as three boys. Okay, I need to make a team of four people satisfying these following two conditions so that there is at least one, let's say at least one boy, and A and P refuse to be together on the team. So, in how many ways can the team be formed? How will you do it? All right, let's take a look what we can do. So, we need to satisfy both the conditions. So, one possibility, you must have at least one boy in it, and A and P refuse to be together on the team. So, let us say there is at least one boy. So, let us say we select P because A and P refuse to be together. P has been selected. Okay. Now, if P is selected, then A is automatically rejected. That's case number one I'm doing. Now, if P has already been selected, it automatically also ensures that there is at least one boy in the team. That is done. So we don't need to select or satisfy that condition separately. It's already satisfied. So both conditions have been satisfied. So P is in, A is out. So of the team of four, I already have one in the team. I need to select, oh, sorry. I need to select three more. So I need to select three more. So it is something C3. Now what's C3? So there are total seven people. P is already in, A is already rejected, out. Five people are left. Select any three from that. So that's 10 ways. Okay, if P is in, A is out, you have 10 ways. The second case, what if P is not in? Okay, there is no necessity that P must be there, right? Now, if P is not in, I am really not bothered whether A is in the team or not. Because P is not in the team, A can be in the team, A might not be in the team as well. Okay. Why did I not do the same logic previously that okay, P is in the team then? Because the condition for P also satisfies that at least one boy is there. So satisfying a main condition. Okay. But here when P is not there, I am not bothered about a girl being present or not, right? So we can ignore the condition for A. So we just know that P is out. That leaves us with six people. We haven't selected anyone yet. So we do 6C4. But when I do 6C4, there remains one small chance that all four girls get selected. Right? There is no restriction on A, mind it. If P is not selected, A may be there, may not be there. So all four girls, A, B, C, D coming into the team is possible. But in that case, the condition that there is at least one boy is not being satisfied. So we need to remove that case where all girls are there, or rather only girls are there. Since there are only four girls and we are selecting four people, so the number of ways all girls are there is 4C4. And that is the only case which we need to reject or need to cancel out. So 64 minus 4C4. 64 is 15 minus 1, so we have 14. So total there are 24 ways of forming that team. Was this clear? This is how multiple conditions based questions, if they occur, then you have to make these cases. That's where the clarity of thought is very important. Because see, basically in PNC, once you have got the logic right, after that it's just doing a NCR or just doing some factorial. That anyone can do. That is not the main part of the question. Okay. The main part of the question is setting up these points, case one, case two, or maybe deciding that this is how I'm going to think, like that. Okay. All right. So now let's move on to another question. Yeah. Can you try this? Let's try this question. So before we go to this question, let's answer this one. Say you have A, B, C, and D, four people. I say that you select any two. So you know, obviously we are going to do 4C2. That's 6. What's wrong if you had done 4C1 and 3C1 and got 12? What is wrong in this? 4C1 times 3C1 is wrong because we are doing an ordered selection. We are selecting the first guy and then selecting the next. So just like we could have done A and then B, we could have also got B and then A. The swapping is there. So to get the correct answer, if you have done it like this, you must divide by 2 factorial. Now it's okay. So now let's come back to this question. So there are 6 couples. Let's call them A1, A2. That's for couple A, then couple B. So these are the 6 couples. And now we have to select 4 people such that none of them are couples. So that means I cannot select A1 and A2 both. So what we can do is we can select the first person out of the 12 in 12C1 ways. 12 ways. So let's say we selected B1. Then B2 is out. So B2 is out. That leaves us with 10 people now. So the second person can be selected in 10 ways. Say we select D1. D2 is now out. That leaves you with four pairs. So eight people. Select the next one in eight ways. F1 is out. Now you're left with six ways. But what you have just now done is like 12C1 times 10C1 times 8C1 times 6C1 is we have done an ordered selection. First this guy, then this guy. So this includes different possible orders, right? We don't need the order. So we need to divide it by four things, right? 4 factorial. That will be the correct answer. So let us calculate that. So 12 times 10 times 48, and that's 24 here. So 240. Okay, there are 240 ways. What else we could have done? There exists another way of doing this. For that, we need to realize that the people that are getting selected, they are part of a couple, right? So basically, we can say that we are going to select one of the two in a couple, not both, one of the two. So, since I need four people, I need to first decide on four couples. So, out of the six couples, you select any of the four couples. You haven't selected any person. We have just decided that my people will come from these couples. Now, from the first couple, select any one of them. We can decide that in two ways. From this, another two ways, another two ways, another two ways. So the total number of ways 64 is 15 times that's 16. So that is 240 ways. I hope this is clear. The thinking process has to be developed in this fashion. So there can be multiple ways of approaching a question. Okay, there is no correct way of solving. There can be multiple correct ways. Okay, no single correct way of solving. There can be many ways of solving a question. As long as your logic is right, your answer will come out to be the same. So you have to focus on getting the logic right every time. All right, let's see. Let us try this one. Um, okay, I'll give you another one which based on letters. So let us say you have all the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you are making four-digit numbers. So how many four-digit numbers have the string 18 exactly as 1 8? Okay, have the string 18 only once. For example, 1827, or for example 3182, or for example 5418. All of them are fine, but you can't have 1782 and say that okay 18 is there. No, that's not what I mean. Together as a whole, this string 18 should come exactly once in the number. How many such numbers are there? And you can use all 10 digits 0 to 9. All right, let's take a look at this. So we have to think on the different positions 1 8 can occur. So starting with 1 8. So the numbers can be repeated. Okay, so 1817 is okay. There is no restriction that all the digits must be distinct or something like that. Okay. So if I start with 1 8, or I have 18 in the middle, or I have 18 at the end. So starting with 18, these two places can be filled in 10 times 10, 100 ways. But one of those 100 ways will also have another 18 coming in. So this would be 100 minus 1, 99 ways. When it is this in the middle, since the starting position, the thousands place cannot be 0, because then it is not a 4-digit number. So we have 9 options for this and 10 options for this. So 90. We don't need to subtract anything because we are not going to get two 18s, 1818 anymore, because 18 is in the middle. So 90 ways here. And same here also, 9 times 10. So that's 90, but then 1 less because 18 will come in, right? So 90 minus 1, so 89. So you just need to add them up. So that's 90, and 90 is 180 plus 100 is 280. 280 minus 2, so 278 cases. 278 such numbers have 18 present exactly once. Is that okay? I hope this is fine. All right, let us take a look at this one. We'll take a look at circular arrangements later on in the next lesson. For now, let us finish today's lesson with this last question. In how many ways can 5 boys and 5 girls be seated in a line so that no two boys are together? All right, so let's see. We do not want the boys to be seated next to each other. That can be easily obtained. You see, there is no restriction on the girls. So you might have a case where you have boy, girl together, and then you have boy, girl, boy. So you have got 1, 2, 3, 4. So how many you have? 1, 2, 3, 4, 5. Yeah. So that's okay, perfectly fine. The two girls together, no problem. The two girls together could be anywhere. We don't know. Okay. So obviously we can't keep on doing it as different cases. What we simply say is, let's first fix the girls. Okay. So 5 girls, they can be arranged in 5 factorial ways, but keeping in these positions only, they are arranging themselves in 5 factorial ways. So that's for the girls. Now for the boys, you decide where to place them. There are 6 possible positions. So you can have a boy here also. That's not a problem. You can have a boy at the end also. That's also not a problem. Okay. So one possibility could be a boy here, then a boy here, boy here, boy here, boy here. So 5 boys, and these 2 girls end up being consecutive, back to back, adjacent. So the question now becomes that 5 girls you have arranged, and out of the 6 possible slots that we have, we just need 5 to place our boys and then arrange the boys in those positions. Now 65 is basically 6. 6 times 5 factorial is 6 factorial. So this essentially becomes 5 factorial times 6 factorial. Right? So till what we discussed here, anyone, if you have any questions, you can ask me now. So in the next lesson, we'll look at these sort of questions, okay, like geometric shapes, like how many rectangles are there, or how many right angle triangles are there, how many roots are there connecting A and B, then different ways of coloring the grid, okay, some other questions, palindromes and all that. We'll take a look at these variety of questions, okay. But before we stop today, you have any questions you can ask. And those of you need the recording, please drop me a message on Leland itself. Okay, I'll upload this on my YouTube channel and I'll share you the link for that. Okay, and if you enjoyed the session, just drop me a rating or review on Leland. That will be helpful. Okay, thanks. Bye.